Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. Um, so today I would like to discuss with you for the next chapter, which is week number 7, technique of integration. In the previous video, we discussed about the integration on how we integrate a simple function, for example, a polynomial, exponential function, reciprocal, and also trigonometric function. Okay, for week number 7, the basic understanding is from week number 6, which is you should master all the technique, all the rules of integration of the function that we mentioned just now. Okay, alright. So for this week number 7, we separate into 2 lessons. Alright. So for the first video here, we discuss about the first lesson we call of integration by substitution, and also another technique of integration is integration by part. Alright. Okay, just a quick recap. If you still remember on how do we integrate, on how we differentiate, for example, by using the product rule. Product rule. We use the product rule differentiation, and we have y in terms of multiplication between two functions. And then for the quotient rule, we use this quotient rule when you have two functions that derive to each other. Okay. Same thing happen for integration. The technique to integrate when you have product of two functions and you have a quotient of two functions, we use integration by substitution and also integration by part. So these two is applicable when you have two functions in the form of product and also quotient, right? So we go one by one. So by definition of integration by substitution is integral which are computed by change of variable is called u substitution. So we like to use a variable u to let one of the function, okay, and therefore we do something with the u, right? So in this we have to change the basic variable as an integrand like x to another variable like u, meaning rather than we integrate in terms of x, so now we change the integration in terms of u. So every single x you have to substitute with u. Okay, and then try from the u, you have to differentiate in order to dapatkan du. Okay, because you know that, for example, u equal to x, differentiate the u, du over in term of x, so you will have 1, right? So from here, you will obtain the du equal to dx. So now, you might change this dx become du. Okay, so we have an example later, and we discuss more detail about it. Right? And this make the integrals easy to determine. And usually, macam I dah mention tadi, when you have a product of two function, seems like it's very difficult to integrate. Like the normal method that we learned from the previous video. Right? So what we can do is kita guna this u substitution. So therefore, the integral is easy to determine. Right? Kenapa? Which is why u substitution. It is one of the simplest integration technique. Okay, so which is the simplest method to integrate when you have a product of function or quotient of function, where we use the u substitution. Also, it can be used to make integration easier. I explained just now. And the third one, it is used when an integral contains some function and its derivative. Okay, right. So, example over here, this is actually the technique. Number one, you have to let u as a function. Usually we let u as a complicated function. Complicated function. Usually sama ada the function ni, for example the function inside the bracket. Okay, for example you have the power 4, so it's very hard to expand. So therefore we let the function inside here as a u, for example. Or some you have square root. Square root of function. So the function inside the square root we let as a u. Okay, later we have an example. And usually as I mentioned tadi on the third point, one of the function is a derivative to its function. Okay, so which is kalau tengok sini example dia, we let fx because we know when we differentiate we will have this f prime. Okay, so sebab tu kita letakkan u as the fx. But one of the function ataupun multiplication between two function ni, one of them is a derivative to its function. Alright. So this is only in the in general we explain. Okay. So don't worry about this slide. Alright. Okay. When to use the u substitution? We have function and its derivative together, or where by use the simpler method like power rule, constant multiple rules, or etc. It's difficult to solve integration. Okay, as I mentioned tadi, usually we use the u substitution when you have a product of function or quotient of functions. So kita gunakan u substitution. Alright. So I'm using this exercise from 20.08, page number 359. Okay, I have a few questions, but in our slide I already explained about question number 12. So therefore, I'm using question number 1 to explain lah. Okay, as a simple example lah. Okay, now, so the question asks to determine these integrals by using a suitable algebraic substitution. Okay, even though the question already mentioned about the method, which is algebraic substitution, sometimes the question didn't give you a specific method to integrate. So therefore, you have to know what is the suitable method to integrate. So you can see from here, even though there is no function that multiply together, but your function is very difficult to integrate. Okay, so what we can do is we let u equal to the function inside the bracket. I mentioned just now, usually we let u the function inside the bracket. Okay, even the question already mentioned that you have to use the substitution as a u equal to 2x plus 1. Katakanlah tak ada this statement. So usually we let u the function inside the bracket. Okay, now, so u equal to 2x plus 1. So definitely you have to differentiate. Kenapa kena differentiate? Because we are trying to substitute our dx in term of u. Because we are no longer integrate in term of x. We wanted to integrate in term of u. So itu kita panggil sebagai u substitution, alright? So therefore you have to differentiate du in order to dapatkan dx. Okay, now differentiate, you have to, is it? So now take dx as a subject, therefore you will have du over 2. Okay, now this is the time when we have to substitute everything. Okay, original question, you have integrate of 2x plus 1 power of 6 dx. And then you already substitute the function inside the bracket with u. So you put u power of 6. I just copy whatever from the question. And then our dx we substitute with du over 2. Okay, now your function, your integrand become more simple to integrate. Okay, now since you have the denominator of 2, so why don't you put outside, and then you focus on integrate u power of 6 in terms of u. Okay, therefore remember plus 1 for the power of the u, and then divide with the new power, and then don't forget to put plus c. Now your function become 1 over 2 u power of 7 over 7 plus c. And therefore, don't forget to substitute back u with 2x plus 1. Don't leave your answer with in term of u, because soalan original they ask you in term of x. So don't leave your answer um, without substitute back the u with 2x plus 1. So therefore, you akan ada ialah 2x plus 1 power of 7 over 7 plus c. And usually, we multiply these 2 and 7 become 1 over 14. 2x plus 1 power of 7 plus c. Okay, so rather than you expand 1 by 1, 2x plus 1, 2x plus 1, 2x plus 1 6 times. So why don't use the u substitution in order to simplify your integration? Okay, another one. Okay, so for this question, actually they try to apply which is to integrate of the one of the function is the derivative of the function. Okay, so now, okay, don't worry this point here. Okay, actually, you just grab this one thing. Remember, choose the suitable u as a function inside the bracket. So the function inside the bracket is over here, which is x squared plus 4. Choose the function inside the bracket. Even though katalah you tak ada function inside the bracket, katalah you ada square root of 1 plus 4x. Actually, you ada juga bracket. Actually, what you have is 1 over 1 plus 4x power 1 over 2. So, this is the function inside the bracket. So, you let u as your 1 plus 4x. Okay. Some of the question will ask you in terms of this one. Okay. Just ignore this one. Okay, now let's solve this one. Right. So remember, you have to differentiate. Kenapa kena differentiate? Because we are trying to change our dx in terms of du. You know, we don't want to integrate in terms of x because your function is complicated. Okay, now differentiate become 2x and put the dx as a subject. Therefore, you akan ada du over 2x. Okay, now let's substitute our question 3x with u power of 2. But your dx is already changed become du over 2x. Is there anything we can simplify? Yes. You boleh cancel out x with x over here. Cancel out. So therefore, what is the remaining? 3 over 2 u power of 2 du. Again, take out the sign outside. Focus on integrate of the u function. So therefore, you will have 2 plus 1 over 2 plus 1. Remember, power plus 1 divided by the new power. So simplify further, you will have 3 over 2 u power of 3 over 3 plus c. Okay, therefore, you will cancel out 3 with 3. Right, so therefore, the only answer is 1 over 2 u power of 3 plus c. And therefore, substitute back your u with x squared plus 4 power of 3 plus c. Sound simple? So therefore, please try the rest of the question from this 20.08. Alright? Okay, moving on. Another example from 20.09 that you can try. Okay, the same thing happened over here. A bit different. Sometimes you have to change the U formation. For example, over here, nanti kita tengok one of the example. Right, so let's start to discuss the question number 1. Right, so they already suggest the U variable, meaning you have to substitute the function inside the bracket, which is x minus 1. Okay, now u equal to x minus 1, so differentiate, it become 1. So dx equal to du. Okay, so now from here, substitute everything that you know. So dx become du. Okay, but we cannot even solve because one of the our variables over here in terms of x, which is you cannot even integrate the whole thing since there is a x variable over here. Okay, remember we wanted to differentiate with respect to x. So what we need to do, you have to do something with your substitution over here. Actually, you will break down, which is you can put x as a subject right now, which is u plus 1 equal to x, is it? So substitute your x over here with u plus 1 times u power of 3 du. So now your function, your integrand in terms of u. So expand, you will have u power of 4 plus u power of 3 du. Now, barulah kita boleh integrate. Okay, remember u plus 1. So power plus 1. So 4 plus 1 is 5. Divided by 5. 3 plus 1 is 4. Divided by 4 plus c. And therefore substitute back the u with x minus 1. So x minus 1 power of 5 divided by 5 plus x minus 1 4 over 4 plus c. Okay. So as I mentioned tadi, sometimes you have your integration consists of two variables. We don't want that kind of variable. We wanted only a single variable, either in terms of x or in terms of u. But without using the substitution, it's very hard to integrate, which is you have to expand this one first. Power of 3. What if I put power of 10? So it's very hard, is it? So therefore, we let by using the substitution method, so we let u as a function inside the bracket. But you have to do something with the u, which you have to rearrange, put x as a subject. Now you have u plus 1. So substitute your x. Barulah you dapat the whole thing in terms of one variable. Okay. Let's try another one. Okay. So now they already suggest to us is u equal to square root of x minus 4. Okay, since they already suggest to us, so we have to use the things given lah, which is x minus 4. Remember this one you have to change in order to differentiate. Okay, so baru boleh buat du over dx. So remember, bring down the power minus 1. So half minus 1 is negative half. And then multiply by differentiate the function inside the bracket. So simplify, you will have x minus 4 negative half. This one times 1, right? Okay, so therefore you have 1 over 2 square root of x minus 4. Okay, but your square root of x minus 4, you may substitute with the u. So therefore you have 1 over 2u. But actually you may leave your answer like this, but I rather I would like to change our square root of x minus 4 equal to u. Easy for me to identify my du over dx. So now my du over dx is 2u. Again, put as a dx as a subject. So I can bring up the 2u. So you will have 2u multiplied du. Okay. Now, we're not finished yet. Substitute the whole thing that we know. Okay. So, x multiplied with u. Our dx become 2u du. Your function in terms of two variables. So, what we need to do is you have to find your x from here. Okay. So, therefore, you boleh play around. Change your surd become squared. So, u squared equal to x minus 4. Now, put your x as a subject. It become u squared plus 4 equal to x. So, now you might change your u squared plus 4 times u times 2u du. Okay, so yang you akan ada sini ialah 2u power of 4 plus 8u squared du. Okay, you might continue till you have your answer. Okay, it's very simple, and don't forget to substitute your u with the function of square root of x minus 4. Okay, I'll leave you guys with this function. Okay, this question is not finished yet because I lack of space. You just continue. Okay, another exercise that we can try as a u substitution is on 20.06. I believe this time is more focused on fraction. So I'm using question number 2 over here. Okay, so again, if you can see from here is no bracket. Tadi ada mention in order to let you find the complicated function, usually function inside the bracket. Okay, for a fractional function, you might let your u be your denominator. You let your function of u as your denominator. Okay, kenapa denominator? Because nanti later sometimes your derivative of u sometimes is a derivative of function in your numerator. So from here you differentiate. What we have is 4x, and again take the x as a subject, so therefore you akan ada du over 4x. Okay, now you have an everything. So substitute this function is become negative 8x divided by u over dx become du over 4x. Can you simplify anything? Yes, which is you will cancel out this negative 8 with 4. Therefore, what you have is negative 2 over u du. So take out the negative 2 outside. So what we have is 1 over u du. Okay. Yang ini yang ada common mistake. Usually, dia akan bring up. Okay. Usually, kita akan bring up. Okay, so it's become u power negative 1 du. Okay, kenapa ni method ni salah? Because later you add 1 to your power. So negative 1 plus 1 is 0. Okay. So it's impossible to solve with power of 0. So what we can do here is actually ini adalah jenis of reciprocal. Reciprocal ada explain in the previous video, which is 1 over function where your function is power 1. So tak perlu bawa dekat atas. What you can do is you akan dapat ln u plus c. And don't forget to put the modulus because the function inside the ln is always positive. Okay, so substitute back your u with 2x squared minus 1 plus c. So be careful when you deal with the reciprocal function. Okay, let's try this one. Okay. So again, we let u the function at denominator. Okay. Actually, boleh try an error. You boleh let u equal to exponent of x. Pun boleh juga. Okay. Kalau you tak suka dengan 1 plus 3x, you boleh let u equal to exponent of x. Okay. But I'm choose the function at the denominator. So differentiate, you can dapat semula 3 exponent of x. Differentiate 1 is 0 because differentiate constant kan. And then differentiate 3 exponent of x. So differentiate this one, you akan dapat semula lah. Okay, now your dx as a subject. So du divided by 3 exponent of x. Okay, now I have everything that I need, which is u and also dx. So the function over here is become 6 exponent of x divided by u over dx become du over 3 exponent of x. Can we simplify anything over here? Yes. So you boleh cancel out this 6 exponent x. You boleh cancel dengan 3 exponent x. So yang you adalah 2 divided by u du. Again, you akan ada reciprocal. So therefore 2 ln modulus u plus c. So what we have is ln modulus of 1 plus 3 exponent of x plus c. Okay. Another one that you can try. Okay. This is also from exercise 20.09. So I'm choose for question number 13. Number 13. So we let again u as a function at your denominator. So you have to change a bit over here because it's easy for us to differentiate. So baru you differentiate. So power minus 1. So power minus 1 over half minus 1 is negative half. So what you have is x of square root of x. Sorry, actually you will have 1 over 2 exponent half. Sorry, exponent 1 over 2 x power. Therefore, is similar to 2 square root of x. 2 square root of x. And then you might change your square of x with u. You can do that actually. Okay. So therefore, it's easy for you to substitute your dx. So therefore, your dx, du equal to 1 over 2u. So dx equal to 2u times du. Okay, now your function exponent square root of x dx divided by square root of x. So this one is become exponent square root of x over u. So therefore 2u times du. Okay. Is there anything we can simplify? Yes, this u you might cancel out with the u here. So therefore your function become exponent of square root of x du. But your function seems like in terms of x, but you wanted to integrate in terms of u. So actually, you might substitute this square root of x with u equal to root of x. So therefore, your function is become exponent of u du. And remember, integrate of exponent, you akan dapat balik exponent, but differentiate of the function of your power. Let's see. So actually, you akan dapat semula exponent of u. So therefore, sorry, ada dua di sini. Put outside over here. So therefore, you will have 2 exponent of square root of x plus c. Okay. Right, so we have done with the substitution. So the next subtopic in the first lesson is integration by part. Okay, integration by part. So integration by part is a special method of integration that is often used when two functions are multiplied together. But I want to change a bit. Not only when two functions multiply, you might also use when you have two functions, when you have a quotient function or fraction between two functions. Okay. So you will see plan for example soon, but first let us see the rules. Okay, by the way, this is the formula for integration by part. Okay, try to memorize this formula, the rules, but don't worry, I still give. I will also give in the question later in exam. Okay, so if you can see from here, integrate u dv equal to u times v minus integrate v du. Okay, if you can see from here, okay, let's say the question give you integrate of x times exponent of x dx. So, one of the functions should be u and one of the functions should be dv, is it? Okay, from the question, we look for the first part ni saja. One of the function, kalau you compare dengan this question, one of the function become u and one of the function become dv. Okay, u and also dv. So meaning seems like again you are going to let one of the variable become u, another one become dv. Okay, but how to choose the u? Okay, this is the guideline. Okay, no standard rule state whether u and dv is to be chosen, but two guideline way to be used. Okay, the first guideline is usually we will let u is normally chosen such that du over dx is of a simpler form than u. Contoh, okay, kalau tadi kita ada soalan integrate of x times exponent of x dx, right? Apa maksud guideline pertama ni? When you choose u, your du over dx is simpler than u. For example, you let u equal to x. Differentiate, you akan dapat 1. Is it 1 is more simpler than x? The answer is yes. So, this is the suitable substitution. And this is the correct choose. Okay. Katakanlah kita ambil u equal to exponent of x. Differentiate, you akan dapat exponent of x. Is it exponent of x is more simpler than exponent of x? The answer is no. It's actually the same. So, it's not suitable to choose u as the exponential. Okay, so this is the first guideline. Second guideline, kalau you susah nak pilih u, you boleh choose for dv. So, dv is normally chosen such that integrate dv is easily integrate. Okay, for example, I choose dv equal to x dx. Okay, therefore, I integrate x dx, I can dapat x squared over 2, is it? Is it easily to integrate? It's very big question mark. You can put over here. Okay, let's say I'm choose dv equal to exponent of x dx. So v into exponent x dx, I will have v equal to exponent of x. So compared to this x and also exponent, which one is more easy to integrate? So that will be this one. Kenapa? Because you dapat semula the exponential. So this is not a suitable choose to let your dv equal to x. Okay, so this is only a guideline. Actually, ada cara lagi mudah. Kita panggil dia sebagai rule of thumb or LIPET. L-I-P-E-T. Apa maksud L-I-P-E-T ni? So, L is a L is logarithmic function. Contoh logarithmic function, ln x, ln 2x, ln 3x and so on. Okay, so you choose u based on which of these come first. The first priority is logarithmic function. L is the first priority. Contoh, let's say you ada integrate ln x times cos x dx. So you choose u based on the LIPET. So L, ln is a logarithmic, cos is a trigonometric. So which one come first based on that? So definitely L will come first. So choose u equal to ln x. Because logarithmic is the first priority. Second priority is inverse trigonometric function. For example, sine inverse of x, cos inverse of x, tangent inverse of x, and so on. Okay, the third priority will be polynomial. For example, x power of n, 1 over x, square root of x, and so on. Okay, that one is the third priority. Even kalau you ada constant, for example, 2. For example, you ada 3. Actually, this constant, you have a multiple of x power 0. But we never write the x power 0. X power 0, we write as a 1. So, sebab tu dia in the group of polynomial function. Even kalau ada constant, So 3, 2. The constant actually in the group of polynomial. Okay, the fourth priority will be exponential function. Contoh exponential function, exponent power of fx, 1 over exponent of fx, and so on. Anything yang involve exponential function will lies at the fourth priority. So choose u as an exponential function kalau you ada in the fourth priority. Okay, and then last but not least is trigonometric lah. Contoh sine, cos, tangent, and so on. Okay, so choose u based on this priority. So the first priority is log, second inverse trigonometric, the third is polynomial, the fourth is the exponential, and the fifth is trigonometric function. Ada setengah buku dengan log pad. Over there is others function other than log, polynomial, exponential, and trigo. Okay, kalau you tak sure dengan this one, you boleh go back to this guideline. Okay, but I really suggest you, I encourage you to focus on this lipat saja. It's really helpful. Okay, alright. So how to solve? There are 3 steps. Step number 1, identify u and dv. Because in the formula or the rules of in the rules of integration by part, remember the formula is integrate u dv, u times v minus integrate v du. So you have to identify the whole thing. You have to identify your u, you have to identify your dv. From u, you boleh dapatkan du by differentiate. Kita gunakan differentiate. Once you ada dv, nak dapatkan v pula, you integrate. Integrate. Di sini you differentiate. Okay. So, macam contradict. Okay, step number 2. Determine the differential of u to get du and integral of dv to get the v. Macam tadi. Step number 3 is substitute into the formula and solve it. Substitute semula dalam rules of integration by part and then solve it. And you can, I already put in the slide a few examples. Okay, they can check out later. But I will try one of the question from these exercises. Okay, I will choose exercise number 1. Okay, question number 1 over here. So based on lipat, LIPET, okay, which one comes first? So x over here is a polynomial, is it? And exponential is an exponential function. So based on lipat, so P comes first. Baru E. So we let U for the polynomial. So therefore we let U equal to X. And after that you choose U equal to X. Therefore the remaining become dV. Tak perlu untuk cari dV. Right, after you choose U, the remaining become dV. The whole thing, the whole thing ambil sekali dengan demi dV. Kenapa? Because you akan integrate into dapatkan V. Okay, now first, U equal to X. So differentiate equal to 1. So dapatkan du. Put du as a subject. So du equal to dx. So next, from dv, integrate, remember? Integrate. So v equal to exponent x. Do we need to put plus c? No need. Because later, kat hujung sekali nanti baru kita letak plus c. Okay, now, you dah ada u, you dah ada v, dah ada du, dah ada dv. So now we substitute the formula. So integrate u dv equal to u times v minus integrate v du. So u awak ialah x, dv awak ialah exponent x dx. So our u is x. Substitute everything that you have list just now. Minus integrate of x. Du awak ialah dx. Okay, so we focus on the right hand side over here because the left hand side is actually your question. Okay, so we focus on the right hand side. If we integrate, the first part over here, nothing happen, we just multiply, just open the bracket, but focus on the integration process over here. So they ask you to integrate the exponent of x dx. Remember, integrate of x, you akan dapat semula exponent of x. And then just simply put plus c over here. So that's it. This is the answer. It's very simple, is it? By using the LIPET rule of thumb. Okay, let's try another one. Right now you have a fraction. By part ni is not only a product of two function, boleh apply juga untuk fraction. Okay, now based on LIPET. LIPET. So this one is actually a polynomial and this one is a exponential. So P come first, is it? P come first. Okay, so the suitable U is equal to x squared. But be careful with the dv. Okay, actually you have to rewrite this question. Okay, kenapa kena rewrite? You have to bring up dahulu di atas. Bring up the denominator, become negative power. Otherwise, you tak akan dapat the correct answer. Because usually tadi ada highlight tentang when we have to use the integration by part. Remember dia kata tadi, when you have two function that multiply. Okay, so sebab itulah kita try our best to change the format of your question. Okay, alright now. So kita dah tahu tadi, right after you choose U, the remaining become dv, is it? So it's become exponent negative 2x dx. So from here, get your du by differentiate your function here. So your du equal to 2x dx. How to get v? Integrate. So integrate, remember you will have x divided by negative 2. Mana datang negative 2? By differentiate the power over here. So sebab tu dapat negative 2. Okay, so now let's try to substitute into the formula. So just copy semula soalan equal to u times v. So u times v is x squared times exponent negative 2 over negative 2 minus integrate exponent negative 2x over negative 2 dx. Oh, sorry. Ada mistake. Let me erase this one. Okay, let's do it again. Okay, so integrate u dv uv minus integrate v du. So let's substitute. So this one actually your question. Your u is x squared. Your v exponent negative 2x over negative 2 minus integrate exponent negative 2x over negative 2 2x dx. Because your du is 2x dx. So simplify further, you will have is x squared exponent negative 2x over negative 2 plus integrate. Okay, over here we cancel out 2 with 2. So the only integration left is only exponent power of negative 2. Negative dan negative is positive. Cancel out 2 with 2. So tak ada lagi. Okay, now simplify further. Not simplify. Actually the process of integration become exponent negative 2x over negative 2 again and then plus c. Okay. You may leave your answer like this, but actually you have to simplify. Simplify. So actually this is the answer. Okay. Okay, a bit different with the answer given, tapi actually you may stop over here lah. Tak perlu nak simplify lagi. Okay, right. So I think that's it for today. See you to the next video.